All right, thanks, Daniel. I'm Jeremy Giddings. I'm with Agriculture Victoria, near Mildura, which is a fair way away, and I'm very conscious of coming here and dumping and then going. So Steph's here. She's the semi-local from Agriculture Victoria. So I've been running courses like this for 30 years along the Murray. But I'm not a vegetable grower, and we don't grow a lot of vegetables. Dan tells me we've got 3 vegetable growers around Mildura, on your books anyway. But the irrigation principles are the same, and the knowledge about irrigating vegetables is certainly on this side of the room, and I'm not here to tell you how to irrigate. Hopefully we can talk about some principles and get you thinking and talking, talk about a bit of the salt issues as well, and a little bit on irrigation scheduling. Before we do that, if we can go around the room, maybe if you can introduce yourself, your name, where you're from, how long you've been growing veggies, and the one thing you'd like to see in today's workshop. And guess what, Adam? We're going to start with you.
Thank you.
And why are you here?
Hopefully to learn a bit about irrigation.
Fair chance, nothing specific. Don't be too, leave it broad. Yep.
No, nothing.
All right. Fair enough. You know. And the one thing you want to see the Savo? All right.
Mason Brothers.
Oh, yeah.
I've been on the farm myself, I think the last 7 years. I'm still pretty fresh from the industry, and I'm just here to learn.
All right. Beauty. Gary?
Hi, I'm Gary, Craig Bunny Farms, so I'm the growing supervisor for the lettuces. Here just to get an understanding of irrigation systems, so about certificates and stuff like that.
Salinity?
Yeah.
Good. And Lauren? And you 3, Steph? And Daniel? And Emily? Oh.
Try to organise things like this that are relevant to the region and bring information to farmers, and then also show up at the farm, just have a chat one-to-one about what is relevant to you and what you might like to see going forward with mentioning.
Okay, I'm Agriculture Victoria, part of the horticulture team based out of Queensland as well. But I sort of cover the whole state, working to support vegetable growers in really in any way they need. For similar roles to Daniel's, but ag based. So yeah, please don't hesitate to reach out if there's something we can help with. Otherwise, and yeah, I'm here to learn about you guys.
Me too. Me too. I'm here to learn as well, and I will learn more. But like I said, the principles are the same. But with such a small group, all of a sudden, certainly give us a yell if you've got any questions. That's what we're here for. If you can't hear me, let me know. But the plan is that Daniel pointed out, we're going to do a little bit on sprinkler systems, a bit on monitoring, go out, and thanks, Adam, go out and measure some cups on a system that's already have run. The Water Authority will come in here, SRA, SRW. Then we'll talk a little bit about salinity and scheduling. And what's going on there. When we talk about sprinklers, every sprinkler has its own specification chart, although the stuff from China is a little bit harder to find. And there's a message in that, but every sprinkler has a chart, and you should have it. You should have it on file. And here's the 5022s, and here's the chart here. And it has the stuff that you need to know. You know, the nozzle colour, the pressure, this one's in bars, the flow rate, this one's in metres cubed per hour. So 0.31 metres cubed an hour is 310 litres an hour. The throw in metres, a diameter of throw, and then some other information over on the right-hand side, which we'll get into later on. And it looks like many vegetable growing areas, that naan or rivulus now dominating the sprinklers. If you're thinking about changing or looking at anything else, just be aware. Here's the Nelson products, and their flow rate is in litres per hour, and their diameter is a radius, not a diameter. Their throw is a radius, not a diameter, so it's about half the numbers that you're looking at on the previous chart. So if you're trying to compare apples to apples, they're not quite the same thing. Just make sure you keep looking at the units, and we'll see that again when we start talking about salinity. The units switch between the provider, wherever you're getting your information, it seems. People use different units. So it's important to know a little bit about your system. We have a problem at home when the blokes come in to the agent and say, I need a joiner or an adapter or whatever for this drip line. Well, what's the drip line? I don't know. It's about this big and it's black. That's all they know. We want people to know a little bit more about their system for a lot of different reasons. To get the brain going a little bit though, one of the important things you want to know about your system is the application rate of your sprinkler system. And it doesn't matter whether you've got sprinklers or drippers or you're flooding. The application rate is a depth, and it's in millimetres per hour, and it's the same units as rainfall in millimetres. It's the same units as what we might measure our soil water holding capacity in millimetres, and it's the same units that many of us measure our water use. You know, 5 millimetres of water use a day, that kind of thing. This is in millimetres per hour, and it's measured by the volume of the water divided by the area that you're applying it to, and it gives you that depth in millimetres. So for sprinklers, for a sprinkler situation, it's the amount of water coming out an individual sprinkler, including the minor jet, if the minor jet is live, divided by the spacings of those sprinklers, okay? And in this case, I've got a sprinkler here pushing out 1,030 litres an hour, and the spacing is 10 by 12. And I divide that into the product of that, and I get about 8.5 millimetres an hour. Okay, does that make sense? 8.5 millimetres an hour. And that's important to know because it drives everything. We've got allocations. We're getting tighter with our water. We've got allocations in megalitres per hectare. 100 millimetres is 1 megalitre a hectare, okay? So it's the same sort of units, and it's handy to know. And this application rate is a product of these three things. And this top one is a product of our pressure and our nozzle size. Okay, and they're going to change between farms and maybe within farms. So to get the brain working, I've got to get you to do a little activity on page 8. Down the bottom there is to whack, and that's in this green book, by the way. I assumed you had one. Whack those three numbers in, and if you don't know them, make them up. But I'm sure you know your spacings. And if you've got in the back of your mind what the discharge in litres per hour out the sprinklers that you've got is, put that at the top. And hopefully you've got a little a phone or whatever and calculate that application rate. And I'll give you a couple of minutes before we come back and talk about that. Give us a yell if you've got any problems. I have got the specification charts for naan 5022s. If you know the jet colour and your operating pressure, we can work on a discharge here. It's whatever you've got. 5022. This is why we're here. All right, what's your... Grab one of them. So single jet is on page 5. What colour? 4 mil, and what do you reckon they're operating at? 40 psi is 400 kPa, which is 4 bar, so it's right down the bottom. And we go across, which is 1,180 litres an hour. You right with that, Gino? Adam, you found what yours? No, I've just handed out the spec sheet. That's an example. No. Do you need the spec sheet? Oh, and you want one? You found your discharge, Gary? Me. You right? Worked out your application? 5, 9. Oh, what am I on here? Page 3.
Or you've just got to figure out 10 type of pump first. I don't know what it is.
So they said he said he had a black jet on its own. So this is a single nozzle, and here's the dual. So he's got a single black. He said they were operating at a certain pressure, and I said it was 4 bar. He went across, and that's the discharge right there. And that's 1,180 litres an hour. Yeah, yeah. And if you've got a dual jet, the discharge is the sum of the two. How'd you go, Adam? How'd you go?
Yeah, I'm on.
What'd you come up with?
9.25.
And Gary, any luck? Did you two do the same one? And they're all the same? The whole farm is the same spacings and sprinkler model. .6. Thank goodness. Righto, so I've only got 3, unless, did you do one, Lauren, for the backyard? Or? All right. So in other workshops, we'd have a dozen numbers up here, and they'd all be different. And the first take-home message of the workshop is that means all of your schedules should be different. If you're growing the same crop on the same soil type, and you want to put on, I don't know, you tell me, 15 millimetres? 20 millimetres? Let's say you want to put on 20 millimetres. All right. 2 hours. 2 hours for this bloke is 19.6 millimetres. Okay? If you're down the pub and you say, my lettuce starts with 2 hours, I need 2 hours and I'm putting it on every 4 days. Well, 2 hours for this bloke is 19.6 mils. 2 hours for this is 17.4 millimetres. Not a lot of difference. Maybe. How many times would you irrigate to produce a crop? So how many 2-hour irrigations would you do to put a 6-week crop in? All right, let's say 20 irrigations. 15. 15 2-hour irrigations. So multiply that by 15 and multiply this one by 15. Can someone do that, please? So they're in millimetres, and that is 2.6 megs a hectare, and this one is 2.9 megalitres a hectare. Again, not a big difference, but 0.3 of a meg for 1 hectare over so many hectares. Has water got to the point where this difference is important to recognise? If you had a farm that was developed in stages and you might have one of those 3 things different, you know, one was done in the 80s and then technology has changed and the spacings have changed or the model has changed. And this is an average only. But anyway, it's important to know this. And if any of you work, I think you're owner-operators, but if you work on this farm and you move to another farm, this is the first number, if you're involved in irrigation, that you'd want to get a handle of. Don't assume that this one's the same. They're all the same. You're down the pub and saying, well, I only need 2 hours. And this bloke says I need 3.5. Well, he might have a low application rate and he just needs to run it for longer to put the same amount of water out. And working in hours is fair enough, but just be careful if these numbers are too variable. Is that fair enough? So that's the first take-home message. Know your application rate. And by the way, that's only an average, and that's assuming a certain pressure. And we're going to talk about pressures in a minute. The bloke we visited this morning flips between different nozzle sizes and double or single jets, depending on where he's at and that sort of thing, and that'll change this number as well. Okay? So everyone's program is going to be different. We haven't even talked about different soil types or crop types yet. Just based on an irrigation system, everyone's schedule is going to be slightly different. And if water keeps going the way it is, and the way it is, this difference, this difference might be important. Oh, will become important. It will become important. So that's only an average of what's coming out of the sprinkler divided by the area that it's been applied to, assuming a certain pressure. And I think sometimes we need to get out there and measure that pressure and make sure. You said it was 40 pound, just to be sure. So the way we do that, there's a normal old pressure gauge here and a pitot tube on the bottom of it. And you have your sprinkler here, and you point it straight at your mate and you whack that pitot tube in there about 3 mils away from the jet and take the highest reading and stay dry the whole time. Okay? There are better pressure gauges that spring on the highest reading, and it's the highest reading you're going to be after. Okay? Just to make sure this pressure is the same. And these are available from Nutrient and that sort of. Oh yeah. But this one's more mobile, so we can go up and down. And we might have a go at this if we can. Discharge is what the plants feel. So with a bit of pipe and timing it off and getting the water to go into that pipe into a bucket the same way as we've got here. And if you've got the minor jet, you have to do that one as well, okay? And add them together. If the spec sheet has got pressures, you know, and we know for the black jet, for the handout that I just gave out, for the black jet on its own at 40 bar, which is about, at 4 bar, which is 400 kPa, 1,180 litres an hour. Do we just assume that's right? If it's that pressure, if we only took the pressure using this, do we need to do the discharge? Why wouldn't it be what the book says? Do we need to do both? Why is that? The nozzle can wear out. Yep. And it gets larger, and so the discharge is larger. Chap this morning said he uses a drill bit at that same nozzle size and puts it in the nozzle and sees if it's snug or not. And that's exactly what we recommend as well. So they can get worn out, increase the discharge, and that's a greater water coming out the jet, and so these numbers will be higher, and you wonder why your bill is a certain way it is. Here's the chap measuring the pressure at the workshop last year at Pakenham. Where do you do those pressures? We want to do them at the extremes, the top and the bottom, and maybe somewhere in between, because this is mobile. And if you've got a submain through the middle of the patch and the laterals are going both ways, do it on the submain. And you can pick up a trend. If it drops significantly from there to there, then there's something going on in here. If it drops significantly from there to there, then there's something going on in the submain. Okay, you can identify where the losses are and make a decision. Fair enough? There's a chart in your book on page 15 where we often have groups go out and measure 9 pressures and 9 discharges and calculate the variation. We're not going to do that today. But just so you know, if you're interested and you do multiple tests and you get multiple samples and you calculate the variation using this equation here, what's acceptable for pressure is plus or minus 10%. Discharge has got to be tighter because that's what the plants feel, and it's only plus or minus 5%. So the discharge coming out at a sprinkler should only be 5% variation across a patch. If you had that information, then you go back to your spec sheet and see if they match up, see what's going on. We've got to take pressures. We've got to start taking pressures, and doing things by eye isn't working, especially with the more modern sprinklers. This is a horticultural example. This is from where I am. It's got nothing to do with you, except there is a row of sprinklers along here under this row of vines. This row of vines is not growing. There's a row of sprinklers. The sprinklers are every 2 rows. The middle row would not grow, and those sprinklers were not operating at the right pressure. But by eye, this is on a highway near Mildura. Everyone saw it. Everyone had an opinion and a theory. The sprinklers looked fine. No one whacked a pressure gauge on it and found that the pressure was half and the discharge was even less. Okay, even though it looked fine. The modern sprinklers are hard to tell by eye that they're not operating the way they should, and you need to get a number. Fair enough? That's all I'm trying to say with that slide there. So this number is an average. It's been deposited out there, but we don't know how even. Is 9.8 millimetres being applied everywhere within those sprinkler units? And Google Earth's been very good at telling us that it probably isn't. You can see on the right-hand side there's some issues. This is one of the 3 veggie growers at home. This is the one you got me on too. We had a stinking hot summer, and you can see that poor uniformity there between the sprinklers. A more diagrammatic issue here is this is poor uniformity down the bottom here. Okay, there's sprinklers here. The water's been applied, and we've got a wet patch here, but we're dry near the sprinkler. This one up here is probably more acceptable. And the exercise we're going to do out here in a moment is try and determine the distribution uniformity. Because if we can get that fixed, all the other issues around salt and around scheduling and whatever really fix themselves. So distribution uniformity, DU percentage, is an attempt at measuring the evenness of coverage of sprinklers. We put cans out on a grid pattern between the sprinklers. The system's run for a reasonable time. Are we going to have a reasonable time? Yep. And then we go out and measure the depth or the volume. It doesn't matter. And we'll talk a little bit about that. The depth or the volume, because we're only after a ratio. We measure that from each can and record it. So what we've done is something like this. between 4 sprinklers. This is you, Steph, I believe. And in your book, we've got on page 20 the recording sheet that we're about to use. So we've got a 6x6 grid here. And what we've put out there, you've got 7 beds. So someone's going to put some extra numbers along one side, and we've put 7 sprinklers down the row. So we're going to have some more figures across the top as well. 7 sevens are 49. We're going to have 49 different readings. We'll break into 3 groups, and you do 2 or 3 rows each. Down here, down there, and another group might do 3 on the other side because we've got 7 rows. Fair enough? Has it been half an hour? All right. Well, we'll wander out. So each of you, please bring your recording sheet and a pen. Before we go, so I talked about whether you can measure the depth or the volume. So we're using these things, which the Irrigation Association make, and there's 2 lots of numbers on them, and they give you depth or volume, one on either side of the catch can. And we're interested in depth today, in millimetres. So let's make sure we're all measuring. One of us is going to be in your group, and they can be hard to see, but it's in millimetres, okay? Not millilitres, ml. We're after double M because we're interested in the depth, and that'll become clearer when we come back in. Clear as mud? And Steph's willing to loan them out. All right. So we'll wander out, grab a hat, a drink. We'll be out there for probably 20 minutes. We'll wander back in.
So, hello everyone. Just explaining what the whole group was going outside to do. So Adam at Fresh Select had kindly run his irrigators in this batch for 30 minutes during the first part of the meeting. And before the meeting had started, Jeremy Giddings and the team from AgVic and myself had gone out and put this grid into his paddock between 4 sprinklers. And you can see in this bay, the bay was 7 beds wide, and so we've got a grid of 7 by 7 of these pots out in the paddock just between those 4 sprinklers. And what we're going to go out there is measure every single one of these pots and see just how much water in millimeters had fallen into each one. And it doesn't matter what order you do it in, but what we're going to do is bring them all together, put them into the Excel spreadsheet and the formula that Jeremy has brought with him, and we're going to use those measurements to measure the distribution uniformity of Fresh Select's irrigation system. And the purpose of this is just to test how good the sprinklers and the pipes and the pressure is out in this field for getting uniform moisture distribution and uniform leaching, uniform wetness in the crop. And back to the next part of the video.
Spreadsheet for now, where we'll enter these cells, we yell them out for me, and we'll calculate what's over here. Oh, what do I do? So it did go for 30 minutes.
Yeah.
So with this one, and we can send you these. We can send you this spreadsheet, or Daniel can, and you can do your own things. But you can choose whether you want to measure in millimetres or mils, and we're choosing millimetres, so it's highlighted there, and it's the blue cells that we want to enter. So we can start with Anna's group. You've got the set of numbers. You did the first 2 rows. Either way, yeah, this one doesn't acknowledge the spatial variability. It's just a set of numbers. 5 and 6. That's 14. The middle row, that was my group.
Yeah. In no particular order?
No particular order.
Okay,
Yeah.
4,
Oh,
4.3, 4.7, 5.9, 6.2, 6.2, 6.2, 5.2, 5.7, 5, 4.8, 4.1, 4, 4, then over the other side, 4.6, 4.7, 4.5, 4.2, 3.5, 3.9, 3.7.
35. 5 rows of 7. Yep. That was 3.8. Okay. Entered them. 7 sevens are 49. There's 49 10 numbers entered. I think it gives it to us over here. It's worked out a mean application rate. We're putting how many minutes it ran for of 9.2, which is in the ballpark of talking about here.
What's that 9.25 before?
The DU, the distribution uniformity, 80%. Who thinks that's pretty good?
That feels okay, but
You need someone to put the hand up first. I think it's pretty good.
when I look at some of those numbers, I thought they were a bit.
Yeah, I know, I understand. But we're never going to get it perfect, but it just goes to show you what the tolerances are possible. Back on the,
So that is good, Jeremy.
yeah. The book says over 75% is good. For vegetables particularly, we're talking about smaller root zones and the inability to chase water. It's got to be good, really good. And the one with Daniel, that picture that I showed earlier with that poor distribution uniformity, that grower played around with a few things and got it up to 92. I was really surprised. 92. I told him you wouldn't be able to get it over 85. You can do whatever you like, and he proved me wrong. So the second take-home message for this afternoon is uniformity is everything. And that number that we calculated earlier is an average only coming out one sprinkler, but we don't know how it's being deposited. It's got to be nice and even. Water prices, water availability, all that sort of stuff means that it's got to be nice and even. When we've done these workshops only 15 years ago, and we get a poor uniformity, the department's message would be just put more water on. Okay, now we say fix the uniformity, whether it's poor pressure or poor sprinkler choice of sprinkler or bad design or whatever it might be. Fix the uniformity. Most of the time it's to do with poor pressure, either too low or too high. So here's a situation, the sprinkler is in the middle, there's no other sprinklers around it. The catch cans sits either side of the sprinkler. If the pressure is too low, we get donutting, it doesn't throw as far. The pressure is too high, and that's a human response. More pressure is better. Apart from an energy, a waste of energy, it gives more misting, and we tend to have more water deposited closer to the sprinkler. What we want is this triangular pattern where most of the water gets deposited close to the sprinkler, and then it peters out in a triangular pattern over here to nothing. We've got that situation. a sprinkler here, and it's put out a pattern like that each side. Where's our next sprinkler going? Over here? Over here? Over here? There. So we've got a sprinkler there. It does the same triangular pattern. And the sum of these two triangular patterns gives us something nice and even. Okay? When you see a sprinkler running, and you see this stream of droplet sizes being thrown 10, 12 metres away, that makes sense with a pattern that we've got that we want a pattern like this. But we've got a sprinkler that's throwing all these large droplets right over here. So why we got less over here being applied over here? Why do we want this pattern with less being applied over here than it is close in here? This is in millimetres. This is a depth. You think about this sprinkler here, throwing these very large droplet sizes all the way over here. If we look at it from the top down, we break, let's do it. We break that sprinkler pattern into 3 circles. Those large droplets are being thrown way over here, but this is the larger area that's got to be applied to. It's also moving faster. Okay, there's smaller droplets in here, but it's moving quite slow, and there's just a misty type stuff in here, probably from the knocker, putting water in close to the sprinkler here. And this area is quite small. Remember, the depth is volume of water divided by the area that's been applied to. This area all around here is larger, so we need those larger droplets. We need a range of droplet sizes. The larger ones get thrown further out to the edge here, and when we overlap the other sprinkler with it, we try and get that nice even application. Does that make sense? Did I lost myself? But that's why we're after that triangular pattern. But when you see the sprinkler running, you see those big droplets being thrown furthest. It's because they get applied to a larger area, make it a depth. You have the overlap with the other sprinkler, it's hopefully nice and even. This is from a paper in Italy. We've got one sprinkler over here, dropping the orange droplets all the way down here and petering off. Got another sprinkler over here with the yellow droplets. It's never perfect like what I've drawn here, but the sum of those 2 overlaps is this sort of thing. That's the type of thing we're after for head-to-head irrigation. Good overlap, nice even overlap. Does that make sense? So for veggie growers, uniformity is so important. We've got small root zones, we've got shallow root zones, and we don't want to have to put heaps of water on to try and make up for dry patches. And the better uniformity you can achieve, the potentially less water you need. If you've got poor uniformity at the moment and you're putting on more water to make up for it, if you fix that uniformity, there's an opportunity to save some water. In Australia, we used to measure uniformity independently with government. We're here, they're putting a sprinkler in, and they've got an array of rain gauges in all different directions around that one sprinkler, measuring this sort of pattern. No, I haven't got that watch. And this is the type of pattern they might get. This is called a sprinkler profile. And this is a poor one. This is far from being triangular. So this is one side. The sprinkler is here. It's producing the same pattern on the other side. And here, this is called, I don't know if you remember typhoons, a terrible old brass knocker type, throwing water all the way out to 18 metres, a bit over 18 metres. You see those big droplets being thrown out there. You'd say, gee, this is a good sprinkler. It throws 18 metres. But between 3 and 8 metres, the application rate's only 1.5 mils. Okay, and if you put that on with another sprinkler on the other side, you just don't get that overlap. We're after that triangular patch. Here's a better one. That's this one. NAN 5035s for 20 metre spacings. And those sprinkler profiles used to be produced by an independent government authority. You could then put in your spacings and it would give you uniformity here. And here's a DU of 39, a terrible one, theoretical. Big wet patches in the middle of 9 millimetres per hour in yellow, and only 2s and 3s, even 1 close to the sprinkler. Under the same spacings with that double jet sprinkler here, we get a uniformity of 76. We don't have too many 1s and 2s or 8s and 9s. It's much more even. Like all good government departments, that independent sprinkler testing service is gone, and now we rely on the manufacturers to provide us data, or we do our own testing. And on the spec sheets that I've given you there, these colours represent uniformity, and there'll be a scale in here. Green's good, blue not so good, and orange is terrible, I think. So depending on the spacings and the pressures, it'll give you uniformity. So the manufacturers have got that now. They've got software packages as well, which you are able to access. The NAN one on the top, Rivulus on the bottom, where you just punch in your sprinkler and your spacings, and you can play around with nozzle sizes, spacings, pressures, and find out what your best uniformity is. This is some of the outputs that you get. This is the Nelson one, sorry, and here's the Rivulus, which has taken over NAN. And it has in here, this is the spacings, 10 metres. Got a flow rate in here for a certain pressure and a certain pressure and nozzle size. And here's the distribution uniformity, 91%. And the chap that we talked about before that got it up to 91, that's his data there. And he got it up to 91 or so from his catch can data, and it matched up with what the spec sheet, the output said as well, which doesn't always happen. This one's done in controlled conditions, you know, with brand new sprinklers and whatever. It's always going to be better than the one out in the field. But if this one's bad, the one out in the field's going to be worse. Okay, we've never seen it the other way around. So this might be, if you're going to play around with the redevelopment, get a hold of this software. It's free. If I can handle it, or Steph can handle it for you, or we can do it over the phone. You can play around and say, what happens if I move this to 9.5 metres or 11 metres or whatever it might be? What's it do to my uniformity? If that one's going to be poor, then the one in the field's going to be poor as well. It's a first cut. Is that fair enough? If you don't want to use these, you can use any catch can, dog tin, whatever you like. These are Chinese takeaway cups, and before these came along, this is what I had to use and put up with them being blown around and whatever. And I just measure the volume, okay? And we're only interested in the changes, the ratios. But if you're interested in the depth, you need to know the diameter of the cup, and there's a table in your chart, in your books, that says this is the diameter of the catch can, just measuring it here. Then you can change the numbers that way and convert those volumes into depth. And that's what I've done here. This is one I did 15 years ago, a terrible uniformity. This one's in a triangular pattern, okay? And I'll put the cans out in a square pattern within the triangle. Uniformity, distribution uniformity calculates the driest quarter of the cans. And I've got 36 cans here, circled the 9 driest, and they're concentrated around a sprinkler. See that? With the measuring tape and converting this volume into depth, the lowest can was only putting 2.3 millimetres an hour out. The heaviest can, 10.8. Okay, massive difference. The average was 7.5. Those averages that we worked out here earlier was 7.5. I haven't got that written down, but the uniformity of that 7 just didn't exist. Okay. So in the past, we used to say just run it for longer to make up for this dry patch. Now we say fix the uniformity. A couple of slides to finish off, and then I'll hand it over. the DU really means if we're not assuming any runoff, if the DU of 85%, which is excellent, it means you need to put about 15% extra on for that driest patch to get the same depth that all the plants will receive. And if you've got a DU of 70%, it means you need to put an extra 30% on, and that 30% adds up. And I've got some numbers here comparing two different systems, same spacings, same discharge, 2,400 litres an hour, 2,300, around that. The difference is the uniformity. If we're adding that extra water to make up the uniformity, it makes a hell of a lot of difference in this situation. This is a horticultural situation, obviously trying to have an impact by giving you the worst case example. But the second take-home message this afternoon is fix the uniformity. It's a water-saving opportunity. It's got some agronomic benefits, obviously, as well, because every plant receives the same amount of water. Generally, triangular patterns. I know you blokes don't like triangular patterns because you want to work the other way. Is that the main reason? But they will give a little bit better uniformity. The higher the pressure to a point, this is why I say it's general, the better the uniformity, the closer the spacings be, the better the uniformity. The minor jet improves uniformity just a little bit as well. Here's an example of a sprinkler profile with a single versus a twin jet. The green line is the twin jet, putting a bit more water closer to the sprinkler. So the sprinkler's here and it's producing that triangular pattern that I talked about earlier. A bit more water with the twin jet. Close to the sprinkler. That's about it. That's all I've got to say on sprinkler uniformity. Any questions? You happy with your system now? 80%.
Happier.
Happier.
All better than nervous.
Good out there.
I thought we were going to be able to get stuck into you. So if you look at the numbers in the blue, as I scroll back up, you can get a feel for the oh no, look in the numbers in the green. That's per hour. We've doubled it, I guess. Yeah, we have. So we put this 30-minute input in. Look at the numbers in the green at the bottom of the screen. 8s and 9s, 8s, 7s, 8s, 9s, 10 and 11, 12, 9s, 10, 11, 12. Oh no, what do I do? Oh. Anyway, you can see the variation, but the way the calculation works came out reasonably well. 80%.
So generally see really uniform tuition and more than that.
Yeah, the minor jet on the yeah. Yeah. Generally, yeah, puts more water in close, gives you that triangulation a little bit better. Yeah. But there's other more important things, and you can say the same about the triangular spacings and all that sort of stuff. You're worried about your minor jet and the blockages with algae and whatever, because it's smaller. But again, if you had the software or a set of cups, you could play around with it and get a feel for it yourself. Yeah. But generally, that's the case. Those four things are general trends.
See that women that was like the show that down that really see things that might see distance from more back in the
Summer, stinking hot, wind.
that line.
Yeah, rain can mask issue. Sure. But I mean, when I started 30 years ago, we would be really happy with the uniformity of 75%. Now the standards are raising. I mentioned the chap back home got it up to 80. Sorry, what did I say? 91, 92. And he's really happy. And I've never seen that before. So
Just by changing the system, fixing this, unblocking and changing it.
he went to 4.2. checked his pressures, made sure they were up. He had a variable speed drive. He went for night time with a still night. Found a scenario that was worked for him. Yeah. I think I mentioned to a couple of you, they weren't perpendicular, the risers. So we straightened all them up.
What did he start with?
He had that, and that would have been in the 70s, which would have been acceptable years ago. Yeah. Like a lot of things, you know, you accept a higher, we expect a higher standard.
Way to go for this. The growers that don't have that option. What I'm just going to straightening most, maybe increasing pressure, what other options?
Making sure it's the right pressure. Planer of the cups with the software.
Yeah.
Read that at the moment.
Okay.
And then maybe playing around with the software saying, what if I change the jet or if I change this with the model?
Okay.
The minor jet improved by 2 or 3%. That's worth worrying about.
Is this going to feel like the money spent to get it from 70 whatever to 90 equal to 30?
He was switched on. He had 4 or 5 different combinations. Then it got down to 1 to 4.2 single. I think that was a single. Couldn't convince him on the second, and he's happy with that. I didn't mind it. It's 3 or 4 things over the possibility of that. And the player in that combination. And that regular software, it should all be on your computer. That one there, you can find your sprinkler model, put your spacings in, play around with it. You don't have to be a tech head to be able to do that. I can do it. And if you've got any problems, we'll give you a yell anyway. Heard yesterday the spring for where it's one of the problems. So it's less than often than West Water being positive plugs. It's tricky. All right, we're going to hold it up there. What are we going to do? Have a break or hand over?
Matthew, he's gonna.
Righto. We're happy with sprinklers and uniformity. The two main messages. What's your application rate? Because it makes a difference, and the water situation has got to a point where these sort of differences are worth acknowledging. But you've got to know that that's real as well. We've done that. You've got to go out and measure that, and it's got to be nice and even. Okay? For all those agronomic reasons, but also now for salt. It's got to be even for salt. Salt just complicates everything. And it's a pain in the neck, salinity. So we haven't had a real problem with salinity in my part of the world for 20 years. Although I've just taken a phone call for a bloke with his citrus and all the leaves have fallen off because it got too salty. We can be a bit theoretical, but it affects the plant in 2 ways, especially in your situation, because you are applying it to leaves, the edible product. Leaves take it up quite well. So you have that toxic burn. And if it gets into the soil, it'll give you this osmotic effect where it's just like putting on too much fertilizer and you burn the roots. And the water can't get into the roots because the concentration of everything is higher in the soil than it is in the plant. And water moves from the lower to the higher concentration. And here you've got the opposite. You don't really need to know that, but that's the problem. And then long-term, and these are short-term effects that happen in the first instance, and then this long-term effect on the soil sodicity, where we have soils that crust and seal off and don't let water penetrate, especially on heavier soils. To put it into context, and you're probably going to be tabled out with all of this, but this can be quite alarming. This is the water salinity levels over here, and this, depending on the volume that you're applying in millimetres, and we've worked out what's going on, what millimetres means for you. If you put on 100 millimetres and the water is 1 decisiemen or 1,000 microsiemens, and this is the problem we're going to have because we've got different units. But if you put on 100 millimetres, we're putting on 640 kilograms of salt per hectare in that scenario. And you're putting on more water than that. So it builds up quite quickly. It can build up quite quickly. And if you're going to apply it, the only way to get rid of it is to push it out the bottom. And that requires extra water, which you mightn't have, and a little bit of strategy, because we want to leach the salt out, but we don't want to leach fertiliser out. We don't want to leach the stuff that we've paid for out the bottom either. So are people familiar with the salinity of the river, of the recycled, or of their bore? And these numbers make sense to them? People familiar with the numbers that they're having to play with? Yep, yep.
That's where
All right.
all, I want to go another
Yeah,
5 fell down.
4.8 I saw.
We're not.
Yeah,
That's what river water's coming in. It's right enough.
yeah, when you look at it that way. But when you look out here, it's doable, and you're doing well with what you got, because all the salt work was done in the 80s, 1980s. And when you look up salinity and how it affects my vegetable crop or my citrus tree or whatever it might be, you get tables like this. And these tables are old and incomplete, and they don't account for modern management practices and newer varieties. They are generic, and they are saying that this is for water quality. Excuse me, ECW is the EC of the water. For zucchini, up until 3,100 or 3.1 decisiemens, there's no effect on zucchini, but you get a 10% reduction when you go to 3.8, and they get lower than that. And your water qualities are all are worse than all of those for many of you. But there's a crop effect, obviously, and we know that lettuce is more sensitive than whatever, broccoli or collie or whatever. So although these numbers are old and incomplete and don't account for new varieties and better modern practices, the order is probably still the same. Zucchini still at the top, and hopefully we've got lettuce down the bottom here. Okay? Here it's saying lettuce doesn't like anything over 900. Starts to lose a little bit of crop at 1.4, 1400. It is old and incomplete, but it's the best we've got, okay? The other thing you'll see if you look up the resources about salt is another salinity tolerance table for the soil. So how much can we allow it to build up in the soil before it has an effect? Okay, and that'll have EC and SE as the thing next to it. That's called saturation extract. and they're a separate set of numbers, different set of numbers. Don't get them confused. You really need to see. And it's saying that if we've let our salt build up above this number, up until this number, then we have an effect. And the zucchini's down the bottom, so it's the upside down. These numbers are higher. They're the other way around. I've got some tables we'll hand out in some modern fact sheets. They're the same numbers from 1985, Ayres and Westcott, the same American researchers that did all this stuff. We haven't done anything since, but it's a starting point. That's all we've got. So apart from a desal, leaching is our only option. Push that salt below the root zone, keep it out of the root zone, which requires extra water. Applying sufficient water so that salts don't accumulate. There's a leaching requirement, and there's a calculation to work out how much extra you need to apply. And it's worth just having a little go at it so that you know that you're in the ballpark. We're not chemists. We don't want to be too mathematical. The conundrum with leaching, like I said before, is we want to leach the salt out, but we don't want to leach our nutrients. So we've got to work out a strategy to do that. There's the extra water that's required. Is that in your allocation? Are you willing to put that on? You've got DU issues. The better your DU is, the better the leaching you'll get, the nice even leaching that you'll get. But whether that extra water creates other problems, just like typical farming, we do something to fix something and it causes some other problem. And whether we get drainage and waterlogging. The leaching required, the extra percentage the textbook says to apply, can be worked out with this formula. You can play around with it. The top number is the EC of the water that we're applying. So we mentioned earlier it's 1, or you said it's about 1. The only other number we need is what do we need to keep it under in the soil? And here this bloke is saying it needs to be kept under 2.5. And they've worked out that they need to be putting on an extra 12% or whatever. So if we're putting on 2 hours, you need to put on 2 hours and 20 minutes. I don't know, an extra 10 or 12% to make sure you're pushing that salt below every time, in theory. Okay? Any questions with that? I think we're going to box up the presentation and send it to everyone. Yep. Now that maths can be a bit hard for some, but there are charts around. There is no, well, there is an app in the moment, but this one's saying, this is as high as I want to let my soil get to. Okay. So back from the chart earlier, what are we growing? Let's choose one. Cabbage, what? Lettuce. We want to keep lettuce under 1.3. We don't want to let our soil get higher than 1.3 decisiemens. So where's 1.3? Let's go with 1.5. These are the soil salinities that we don't want to let it get higher than. These are the water salinities that we're using, that we haven't got any choice in using. What's our soil? What's our water salinity? Where are we going? From the river?
Yep.
Which is what? 1.2. 2 is here. We don't want it to get it above 1.5. Where's it line up? Crikey, it's saying, in theory, we're meant to be putting on 36% extra water to keep that salt out. Okay, we've chosen a sensitive crop and we've chosen a high water source, high salinity source, a water source with high salinity, and those two combinations have said in theory we're meant to be putting on 36%, which is impractical, not going to happen, but that's what the book says. But that's telling us the challenges that you've got with those crop types and those water sources. So there's a relationship. You can see smaller numbers in this corner here because we're growing crops that are more tolerant with water that's less salty. The message is that as the water gets saltier and the crops get more sensitive, So these can't handle salt above these numbers here. These are smaller numbers here than down here. The crops in here would be tolerant of those salt levels. We get higher numbers on that part of the chart. And that's a challenge for you blokes. 36% isn't practical. It's too much and it will create those other issues. We don't know these newer varieties. They're obviously doing very well. But there's a long-term impact. There's a long-term impact. Yeah, yeah. Yeah. And that'd be of the soil. Yeah. Yeah, I know. And we're not going to have this is an awareness thing here to show you just how challenging it can be, and be aware. There is an app on there where you can type in the crop type, the water quality, your soil texture, your irrigation system, and this one tells me that we need to put an extra 31% on 31 mils. So it puts it in millimeters. But most of the time, for the irrigators in my part of the world, we're talking an extra 10%. So our ECs are 0.5, 500 microsiemens. Yeah, yeah. And we're applying it where we don't wet the foliage. And the root system is about 10 times more tolerant or excluding salt than leaves are, okay? So we went to drip. So we're doing that through drip. It gets worse into South Australia. Yeah, yeah, because there's groundwater that seeps into it. Yeah, and it's quite bad at the bottom. Just another table. This table's trying to tell us that the better our uniformity, we've done all that stuff on uniformity out there and in here, the better our uniformity is, the less extra water we have to apply. Okay, another reason to improve or maintain and be aware of good sprinkler uniformity, because those dry patches will leave salt behind. If we want to leach those dry patches, that's extra water. What are the wet patches in the sprinkler pattern? What are they doing? They're getting even more water, and that water is definitely lost. So it's got to be nice and even. Then we got to ask ourselves, is that extra 10% or the 36%? Do we need to put that on every irrigation to keep that salt out every time? Geez, I hope not. We couldn't. So we're starting to get a bit more strategic with the way we do things. We're monitoring salinity in our own root zones and just keeping an eye on it and seeing if it's creeping up too high. And there's 3 or 4 options to do that. We've got these sorts of things where the porous, a bit like an old tensiometer, where this is under tension and it's taking a water sample out of the soil, and then you get that analysed yourself and measure that for salinity. You can also measure nitrate in there and see where your nitrate's at and do different depths. We've got this thing called the full stop, which collects water, and you can have a little cable coming off the bottom of that. I've got an old full stop here where you install this below the surface. It's got a little spaghetti tube coming out the bottom. You have that under tension. All the water gathers in here, and you get a water sample out of the soil and see how salty that is. Or you can do your own lab work where you take a soil sample and do this 1 to 5, and we can talk about that all day. But you shake it up, get the salt out of the soil and measure it with a normal old EC meter, which is the same as your pH meters, that sort of stuff. There are options around. Spoke to the Mewers chap yesterday, and he talked about looking at sodium levels in the pedioles when you do plant sampling and seeing if the salt is building up in the plant as well. Those sorts of things to see if it's starting to become a problem, and then you might have to put that extra amount of water on, so that we don't have to put that extra amount of water on every time. We'd be a bit more strategic because we haven't got the water or the energy to put that extra water on all the time. An example here, this is in a vineyard, highly saline water being used. He used the soil sampling method here, which is the green dots and monitored his salinity over the season. Big rainfall event here in blue, didn't do enough. Another rainfall event here, didn't do much either. And it took some winter leaching with all this consistent rainfall to knock it back down, back into the comfortable zone. He was above the threshold, that blue table that I showed earlier. This is for grapevines, this is the threshold here. All the readings were above. And it took some strategic leaching and monitoring and some fortunate rainfall to get it back down later in the season. But this is the challenge we've got. Rainfall makes things better. There's tables around to say you need to create some leaching, but if you get a lot of rainfall, which is clean water, it'll strip that salt out of the profile and give you a little bit of relief. But the problem is, if we've got low allocations, high salty water, and we haven't had any rainfall, then it will accumulate in our root zone. 500 to 550 annually. 600. Yeah. Well, that's, I don't know if you call that a lot. I do. We come from 250. Yeah, yeah. So all I'm talking about here with the salt is an awareness issue and the challenges that you face. EC is a generic term for salt as well. It's all about electrical conductivity, 2 electrodes in a water sample, measuring how conductive between 2 electrodes and all the salts influence how conductive that is. And it can be fertilizer, it can be boron, whatever. So sometimes it's worth getting your water analysed for the elements. Chloride and sodium are the 2 major components of salt, and see whether the water analysis is within CUI there. The other issue you need to... Rainfall. And I think it rains the most in October, long-term average. So that might be a refreshing thing for the start of the season with low... You don't have a season, it's 12 months. Oh. It might be refreshing for the soil. The other thing to think about is what fertiliser you're using. What's the salt index of the fertiliser you're using? And have the salt levels risen to a point where you might have to think about what fertilisers you're choosing? So this is in the book, the fact sheet that I haven't handed out. Sorry, and we better do so. Salt index of fertilisers is just a numerical measure of the salt concentration compared to sodium nitrate, which when they created or invented the salt index was a very common fertiliser. So sodium nitrate up here is 100, and any readings up around 100 mean there's a high salt index. So usually nitrogen fertilisers and potassium-based fertilisers have a high salt index. Obviously potassium chloride is going to have a very high one, 116. Ammonium nitrate, unfortunately, is up around there. Okay, that might be worth thinking about the salt index of your fertilisers as well. You're not shandying different water supplies. Are you mixing them? We can give you a calculator if you like through Daniel. Now this is, don't laugh, but if you're trying to keep it under 300 and there are two different water supplies here, you can work out the ratios that are required to keep it under a certain amount. Your two water supplies might already be above the amount that you want to keep it under. But there's the option there. So what are people doing about salt? Gypsum to open up the soil and try and make that leaching easier. Deep rip to open it up as well. Hopefully not bring it up. No wings on your ripper. It's just leaving it down there but opening it up. But it all gets back to leaching, but you're making the leaching easier or better somehow. Hope for rain. But it's a challenge. You're growing crops that are sensitive. You're using an irrigation system that hits the edible product, that hits the leaves, that is most sensitive. You haven't got subsurface drip, which wouldn't be an answer for that problem anyway. It's certainly a challenge. And given the old numbers, it suggests how the heck is this happening? Given the work that was done previously and the tolerance levels that are supposedly there. I think you've done fairly well. Couple of ideas. Generally, again, DU becomes even more important if irrigating with saline water. I hope they've hit that on the head with the earlier stuff there. What about nighttime irrigations? And probably better? Yeah, disease. Do something, create, for certain varieties of certain crop types. For different crop tolerances, the discussions we've had the last couple of days, lettuce growers are shrinking because it's the most sensitive. This acidity thing is the long-term problem because of salt. Oh, right. So they're not necessarily more tolerant, but they're just further away from it. Wow. Farmers find a way. Find a way. The acidity is the worry long term. So the sodium part of salt collapses soil. That's why gypsum becomes important. Doesn't let water through, and then you got real problems. This challenge between leaching the salt out and trying to keep your fertiliser there is all about timing, trying to find a way there. And if you're managing the salt in this kind of way, obviously you try and leach once a year or whatever is required, and do it at a time when you're certainly not adding fertiliser, and do it in the right way around. But there's some monitoring options available there with those suction tubes, the full stop, that red thing that I had, doing your own sampling, which you don't have to be a chemist. You don't have to send things off to a lab to determine your soil salinities. You just need some basic tools. Any of that helpful? Worth thinking about? The blokes we're talking to are after a magic bullet. It is what it is. Apart from desal and treat the cause, and then all the issues around having to apply gypsum and the extra leaching and all that sort of thing would start to take care of itself. Any comments? Barley, we have that theory at home. Barley is a tolerant crop Tolerant doesn't mean the salt just disappears. You got to bale it and remove it. Salt push. It takes a little bit out. Lucerne, we have the theory that lucerne is tolerant. Lucerne opens up the ground a bit like gypsum and allows the better leaching to occur. That's why we get a better response after lucerne. Yeah, harvesting and taking away.
Anyone doing that?
Not a lot.
Benefit enough for anyone to actually be doing that?
I haven't seen it, no. Be worth asking some questions, looking at it. Yeah. But the volumes, remember that first table, the volumes that are in the soil and the amount we're taking away, not enough. Yeah. Maybe de-water as well. Drop the water table. Lucerne does that. Yeah. But this scenario, the problems here is not water table that I'm aware of. It's what we're applying. Yeah. So we don't want a water table. That's another, but it's probably more manageable. Yeah. But it can be as salty as seawater. 30,000, 50,000 EC. You want to keep that down there. Yeah. Last little topic on scheduling. We could do a whole workshop on scheduling. Some of you may have played around with probes in the past and thought they don't work and they're a pain in the neck. I'm a fan and we can get them to work. Vegetable growers generally are the low adopters of this because of the way the scenario is. You get the thing in the ground, by the time it settles in, it's got to come out. Doesn't make any sense. The data doesn't make any sense, that sort of stuff. I think we're getting better. There are options around now that don't require cabling and batteries and big things. And, you know, this is the original EnviroScan capacitance probe, you know, fairly clunky, takes up a bit of room, had a cable connected. We've got away from all of that. We can install I don't know what I've done now. What are all they? Only 15. Sorry about that. Centec drill and drop the images, the top 3 images here. The access tube's only about 1 inch. You put it in yourself with a drill here. It's tapered, so the diameter at the top is bigger than the bottom, and it slides straight in and pops straight back out. There's another one here, Crop X. This type of thing, the sensors are in the edge of the thread here, and there's one at the bottom. You screw that in, leave it there. It's got a little antenna here, and you screw it back out when the time comes for harvest. But I fully understand that their history and the way they are, by the time they settle in, the harvesters, the crop's nearly done. These options settle in a lot quicker. You want them to start giving you data straight away. And that's what they start to do. So they're starting to make it better for pastures and vegetable growers with their different options. Temperature. Yep. Yep, it can do salinity as well. I changed the frequency on it. That'll be a different one. Yeah, this is all about subsoil, what's happening below the ground. Yeah, but there's others that'll measure leaf moisture, which might be related. Need one. Want farm to start with, and get familiar and get comfortable and see that it can make a difference and learn from it. And because they're so mobile, you can put them in different crops and learn we had a lot of adoption of these sorts of probes in the 90s and early 2000s, and since then disadoption. People, a fox will chew the cable or something and they don't fix it, but they say we've learnt enough. I'm not going to put it back in. I'm not going to pay for the consultant to put it back in. So they don't use it, but they adopt what they learnt from when they had it in there, and you can learn plenty. And well, we talked about yesterday, isn't there 100 of these sitting in a shed somewhere from a vegetable project?
Second year, pretty much all of them have been run over by tractors.
Oh, that makes it hard. Well, maybe that's the crop that's not suited to, but yeah, so it might be more suitable for them. But these things should start, if they're installed properly, you don't need the agronomist to come and install them. You can do it yourself. They should start giving it straight away, because the contact with the soil, if they're done properly, should give you data almost immediately. And when you become more familiar with what you're looking at, it starts to make sense. Half the battle, or the main battle with these things today, is that the new business model for nearly all of these blokes, and there's so many options, that's another problem. It's overwhelming with all the different options, but none of them give backup and support like they used to. The business model for today for them is, we'll install it, you go away and use it however you like, and get your own agronomist to interpret the data and give you advice. And our agronomist group back home, I have met with them and said, hey, you boys, you've got to start learning how to read this data and know what this means. And they're not really interested yet, but they're going to have to, because the business model is that there's no backup and support anymore. It's too expensive. And there's a lack of knowledge. The irrigation agronomists are shrinking. So we run a workshop on half a day on interpreting this data, and I'm going to give you that in 3 minutes, 3 slides, and hopefully make you think about the value of technology like this for your situation. And I'm only talking about capacitance probes here, and there's 10 or 12 options. When you look into it, most of them are using the same probe. It's a sealed probe, and they'll have a sensor every 10 centimeters. And they've jazzed it up with different bells and whistles and called it a different product, but they're generally the same probe for 3/4 of them. And they log every hour. And you can tweak them so that they can log even more frequently than that. So if they're logging that frequently, you can pick up what's going on day to night, okay? So here water use is dropping, and it drops during the day, and then water use stops during the night for a little bit, and then drops during the day and eases up overnight again. That stepping makes sense because it's day and night, but it also indicates root activity, root zone depth. So if you know where the roots are, you can make decisions about how deep you want to apply your water and where you want to push the salt to. So this is a split level graph, and it's got a sensor. It's got 1, 2, 3, 4, 5 sensors. We don't know the depths. Each of these peaks are a different irrigation event every couple of days. If we look at the stepping on the far right hand side, we only get stepping on the first 3 sensors. The bottom 2, there's no stepping after an irrigation, before or after an irrigation, so there's no roots there. So why do we push water there? And why do we push fertiliser there? So if we go back into our irrigation diary and say, hey, this was 3 hours, and I've pushed water down to these depths and there's no roots there yet, I'll shave it back to 2.5 and see what it does. And I only want water to get to the bottom of the root zone. and a little bit extra, especially with the salt floating around. Okay, but I don't want to give it too much that it all goes down the bottom because it doesn't come back. Okay, and it takes our fertilizer with it. Complicated chart here, which is daunting and turns people off this sort of technology. But when you start getting used to what it means, it can become useful. The one message I have in the workshops about irrigation scheduling is recognise the stepping. This is a vegetable crop. Start of the season, each of these irrigation events. There's no stepping on this second sensor, which might be at 20 centimetres at the start of the season. So there's no roots at 20 centimetres. And all these water events that push water right down to this pink line and a little bit at the green are all wasted. Common sense, but it's saying put less on at the start of the season. The roots are only this deep. Then we start to get stepping as the roots start to penetrate that depth. A couple of days later, stepping at this depth. A week or two later, we get stepping at this depth, and we can make decisions on how deep, how many hours we're going to apply to start pushing water to only where the stepping is. And it starts kicking in at this depth down here, 4 or 5 weeks later. And our volumes will increase then like you're already doing, but with a bit of science behind it. Yeah. So each of these peaks are where water got to. And we didn't get water to this bottom layer except for that little event here. That could be your leaching one when there's no fertiliser going on here. I don't know how your agronomy, but that might have been your leaching where you push that little bit below and you can be sure you got it to that depth, and then it doesn't happen again for another couple of months. But the stepping from the capacitance probe tells us our root zone depth and gives us an idea on making some decisions on irrigation volume, hours. You work in hours and that's fine. And there's nowhere on this where it's written, this is 2 hours and this is 3 hours. It's just through experience. And that's where they might have the probe for 1 year and say, well, I needed to start upping it to 3.5 hours come January to get that depth. I haven't got a probe in there, but I'll use those learnings for the future. We had probes in asparagus. Big fern is produced in the off season. And we learnt that 17 mils, they typically put on 40, 50 millimetres of water. 15 to 17 mils was getting held in the fern, in the foliage. Okay? 2 and a bit hours worth of your irrigation with your application rates that you've got up here is being left in the foliage. For those blokes that are only putting on 2 or 3 hours, not much is getting in the ground in the roots where the water gets taken up. They're the things we've learnt from this sort of technology.
Jeremy involved as well. That
Had it for the season, that kind of thing.
yeah, that'd be value.
I think there's nothing there personally. I mean, it's spitting out data that we're guessing.
Yeah.
So we think we know.
We all did.
But the reality is there. So it's not, my only concern is when I've looked at it, I've always taken the mindset that we go down this path. It can't just be one. We grow 4 different crops on site. Each crop's got different yields. Every paddy's different. So it's not like we've got you start on the next day. So we've got all these times and then go, well, we're going to bank on this one. And then what do we do with this graphic? But I think you said something earlier that resonated. You need one. Well, it's going to learn. You're just going to start to understand how you think versus how the data comes out. Rather than whether you got 10 or 100, that'd be great that you told me. But if you've got one, you'll talk to that and you'll tell you how you think versus the data. Then you may change your application method on other plots because you know it's more sandy, or you know it's more heavy, whatever. So sort of soothed my mind a little bit in one sentence how you approach it, right? Because I'm like, if I'm going to hand these tools to the staff, I need multiples, and so do they. Because I've got a copy of this vehicle, I've got a block over the display here, I've got all the different sorts of things happening. It's really not about it. It's about really testing your own theories and your own.
Yeah. Exactly right. We've had failures, growers getting turned off when they've put in 35, and it was too much at once. 35 sites. Start with one. These things aren't cheap. We had a loan system at home, 5 different probes to 5 different growers, and all of them purchased the system once I took it away from them the year later because they became used to it. And I said, go away and irrigate the way you normally irrigate, and then we'll go back and go through it and we'll learn and things will get picked up.
That is part of it. Go back. Yeah, as scenario. Leave it 2 hours. Where did you want the water to get? I don't know. I just think that's
Yeah.
making things right. But have you pushed too far? Have you not pushed far enough? Is it an hour?
Yeah.
I think we can change the relationship.
Has water got to a point where that makes a difference, that 20 minutes over a season?
Well, at the moment, that's not.
Yeah.
And then we do solve it.
Yeah.
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 Gary said before, there's certain crops that have got shallow roots, right? They're chasing for 2 hours.
Yeah.
But then don't let it.
And that's the thing. It's not just for water, it's for cooling and all those things. Yeah. Yep.
Pull a root out and check everything off the old way. The other one, I think it was down to 600. Don't quote me. Could have been 600. But it also told you salt was a different level.
Yeah.
That's how you tell what you see is when you drip at a certain level of liquid shower, the done delivery integrity. Start to see the behavior of salt change. I just always got shot on multiple crops. I think it's on the 5.5 irrigation. I think 30 seasons. It's a full-time job, something that maybe
No, they've gone the wrong way.
But
They've gone the wrong way. Start with one. You blokes are finding a way to produce in the circumstances that you've got. You'll find a way to use this data in your own way as well, somehow. And for the ones who are using it successfully with vegetables, they might have 35 patches and they've got 5 probes. And they'll be in representative sites and they'll start a sequence because they know their farm. And the one here that says it needs a drink will start a sequence for those other patches because they know they're a day behind through experience. And it'll start that sequence. Yeah. Some of the things we learned, which are common sense. So you've had a go, but you've been, well, that's happened, but you might have been, I mean, we have farmers that take 18 months. Yep. Yeah.
it's right. It's trying to be consistent. So you've got a nice little blurb pattern, but it's also pushing that slope down. So you're not stressing the plant down. You keep it consistent.
Yeah. Consistency.
Yeah.
And digging is,
when the plants get bigger, really want to hit it hard.
yeah, and get it through the canopy as well. Digging is great, but it's time consuming and all of that. And yeah. But not everyone is thinking that way. And these things are responsive. You don't have to go out and bring the logger back to the computer anymore. You can have it on your phone and on your office and whatever, and give you alerts to say this patch is getting close and all that sort of stuff. So I think they're getting better. We've learnt so much from them. Just one message, one day versus night. We've got 6 irrigation events here. The first 2 are at night, the last 2 are at night, the middle 2 are during the day. Same number of hours. And the middle 2, and I kept saying to the grower, what's going on? He said, it's the same number of hours, the same number of hours. The farm manager says I've still put the same number of hours on. I stretched it out and worked out that these were daytime irrigations and these are nighttime. And we're getting into it a bit here, but there's 2 ways of presenting the data. And this is the sum graph where there's one line and it's quite easy to interpret. Same number of hours, 30% less water is going on during the daytime compared to the nighttime, and it's coming back down to the dry point 30% quicker. So he's having to put on 30% more water to run it during the day than the night, and having those diseases at night time or whatever. But they're the things we've learnt, and people have changed their practices as a result of those things. Okay? I guess that's just about it. We've only got 4 or 5 take-home messages. Know your application rate. Make sure it's uniform, because if you're interested in these sorts of probes, half the risk is they only measure a volume of soil as big as a tennis ball. So you've got to be having that even application rate. The water has got to be being reached. The water has got to be reaching this probe. Understand DU, maintain it, get familiar with the software, or get your kids to, and play around with the best scenario, especially if you're going to redevelop. Try and aim for those high 80% DUs. And we've got this salinity and scheduling interaction. And the salt issue has just made scheduling an even more important issue. And part of the problem with the blokes who are flogging this gear is they're saying it'll save you water, and we haven't seen that. Quite often our applications go up. If there's a bit of salt around, we want them to push that extra water in to keep that salt below. The applications go up, but we see a plant response. So it's not all about saving water. It's the agronomic. Yeah. And maybe a bit of less saving once you become confident and trusting, the less digging. That's what we've seen. So that's about it, Dan, unless you've got any other questions. Just some thoughts. I can see the challenges with the salt and the water supply. And you've done well to be where you're at. But that's about it for me. Oh, so there's some contact. Go from the top down. But I'm conscious of, being here one day and gone the next. Give us a yell, we'll answer the phone. One of us will. And we'll find a way and work through things. And we're happy to do that. Happy to be here. Yeah.